Hello YouTube viewers, welcome to my channel Science to Technology. In today's show, Science Thursday, we're going to talk about oscilloscope. Now, do not pay attention to that because here I want to create a tutorial that works on everything, every type of oscilloscope because the core remains the same. So let's get started. The first thing first, you must figure out which oscilloscope you are dealing with. So what does that mean? That simply means figure out which brand it is, which model it is, and find its manual. If you're lucky, a few years ago, you could actually find the printed copy. Nowadays, they are not there. You have to download PDF online, either print it out or if you are comfortable reading it on computer, do it. Now be mindful, if you are actually going into oscilloscope, like buying an oscilloscope, do it before you buy it. Like, trust me, you will know far more about the product if you actually read the manual, because manuals are required by the law and they actually have all the details that a reviewer cannot cover, because it will become 5 or 6 hours long. So it's generally far more advisable, before you buy a product, read its manual, not its brochure, its manual. So I started with that. I have some idea of how things go, and there is this extra paper that I found, that is probes. Now this is one thing you must understand: the probe of an oscilloscope is not just a cable, it is an antenna, sort of say. So let's start with a probe. So why do I need to do things with it? Well, first thing is, how do you know this is working properly? Well, there is a very simple solution for it. Look into any probe manual. Generally they will say you have to figure out whether it's giving a square wave input as a square wave output, meaning you put square wave in and you get square wave out. That means this puppy is working. Now question becomes, where do you get the square wave? Every single manufacturer generally has a signal generator for this exact reason. So let's connect this puppy. I connected it, and now this location, again, pay attention to your oscilloscope, look into it, read into it. You will find a place where you can connect the ground and connect the terminal, so you can get the square wave signal. So let's do this. So I'm connecting the ground now. Now I'm connecting the signal. Voila. Now something happened. Now here's the, unless you are very lucky, you will only get something like this. And you can try to press auto button, but generally do not do that, because again, you need to learn how these things work. So there are only two things in every oscilloscope: X and Y axis. And trigger is just like how you fine tune it. So, okay, one is time, one is amplitude. So every axis generally gives you two control. Specifically amplitude. Amplitude is, I can zoom into it. Okay, I'm zooming into it. And again, you may hear click, click. That simply means the relay in the oscilloscope is switching. So do not be panicked. You can, yeah, do not panic about that. Tuk, tuk, tuk. It's a simple thing. So, okay, I get that. Now, okay, I'm not happy that it is bottom. I want it in center. Generally, there would be another position or a zero button. You can press it, or you can zoom in, basically upset it up, put it down. That's up to you. That's for convenience. Be mindful. This space that you are seeing, whatever oscilloscope you are dealing with, it's a virtual space. And anything that, any mathematics, any observation has to be done in this virtual space. So it is kind of necessary that you have signal inside. You have to understand that signal must be in this zone. You must be able to see it, only then the calculations will work. I'll expose this part in the further demonstration. So let's say I made it bigger. Okay, but it start to clip. Okay, no problem. I start to bring it down. And generally you want to have enough oomph. Like, again, why it's going up? Amplitude was a bit much. Okay. So now I'm happy with it. Enough signal is coverage. Why it's freaking. Okay. So I'm happy with one axis of it. Basically, amplitude, I'm getting everything that I need to see. Then becomes the second part. I zoom into it. Now I'm doing temporal zooming, meaning this axis is time. You can see the units are changing. I'm going from, let's say this location is 10 millisecond, 2.8 millisecond. Now, generally, whenever you are doing something fresh, you will have this issue where things are not stable. They are going tinky-chicka, they are dancing. So what does that mean? That comes to the third part. These are the only three things you must understand: amplitude, time, and trigger. Trigger, you see the T symbol there. Again, every oscilloscope will have a different symbol for it. That's why I read the freaking manual, and there will be a knob for it. You go YOLO on that knob. Ta-da! These are the only three things you must understand. Everything else is an add-on on these three core components. So now I have the trigger. Now, okay, I'm seeing the correct square. Now you may want to like, hey, I want to zoom in. You can zoom in. Ta-da! You're like, okay, I still a square. And you may be like, hey, I want this line to be here. No problem. Same way you can do with amplitude offset. You can do offsets here. Okay. Now be very gentle with it, and generally most oscilloscopes have a fine mode. Basically, this mode is very, janky. I can press it. Now I can zoom. So I'm like, okay. Now I'm happy with it. Okay, so that gives me one very clear knowledge. My probe is working. I do not know anything other than that. I just know that my probe is working within square. That's why all oscilloscopes have a signal generator. Again, they do not give you advanced functions, but they will give you the square wave so you can test the probe, read the manual, and again they will show you what's supposed to be the outcome. Another thing is that tiny thing, you must pay attention to the multiplier. So let's say I disconnected it. Now you will find, not in all, but most of them, you will find a switch that says X, 1X or 10X. Now do not go too deep into it in early stages. Of course, you have to figure it out in the later stages, but early stage, do not worry about it. Only thing is, pay attention, the software and the hardware are in the sync. For example, this switch is at 10X, no problem. I go to the touchscreen part. I really wish I had a touchscreen TV, I could touch it here. So you see the probe is at 1X, that's not good. If either I can switch it or that. Generally, it's recommended to keep both of them 10x. So I am touching there. Yes, this oscilloscope does support a screen externally. That's why I was like so tempted. 10x. Voila. You do not need to do anything other than that. Just these are the bare minimum that you must do. Now here's the deal. If you have floating ground, floating neutral point, so to say, yeah, it becomes an antenna. You need proof? Let's zoom into it. Run now. Now let's run into it, and this will be your first test. Disconnect from the square wave generator that your oscilloscopes have, and then try to find a signal, and you will always find a signal. Zoom into it. It's like, okay, it's like, let's try to. And here's the deal, this is what you have to do. You have to feel your way. You are not gonna get like exactly what you're looking for. So you can move the trigger also. The C trigger is very noisy, so I'm gonna move it up. So stabilize it to some extent. Okay. Now, like, what is the signal? There is something. What is it? Well, it's the 50 hertz of my nation's electrical grid. Every electrical wire that I have in the house is emitting that 50 hertz hum, and this puppy is capturing it. And you want to increase its sensitivity, just add a big wire to it. Tada! Nothing. It wire does not have to connect to anything. It's just an antenna. So now you can get actual. Let's see what happens if I connect the ground. No, it's like time wise. That's why. Now again, if you are in US, you will get 60 hertz. If you are in India, you will get 50 hertz. And again, it won't be very stable. I actually got a stable signal. Nice. So these are the core component. You must read the manual. You must understand X, Y, and trigger. There is nothing more than that. If you understand these three things, everything else is built on that. So be comfortable with it. Just have a probe, hanging probe, and just figure out this thing. You have to understand intuitively. It's like, what is happening, where is happening, because every time you're not gonna be like, this is like offset, what do I do? Again, move a knob. Move a knob. That's up to you. Just move a knob. There is nothing more than that. X, Y, and Z. So X, Y is the coordinate system. Yeah, see. Go YOLO on it. And generally, if you are not touching it with mains, you should not have any chance of frying this puppy. Most of the modern scopes are quite robust. So this is how we started. Okay, now I know two things. First, my probe is working. Second, my probe is an antenna. And now I want to see some symbols. Now here's the deal. If you are starting out, the likelihood of you having a square wave generator or a sine wave generator or a full-fledged signal generator is very low. But you may know this sort of tada device, very cheap, hyper cheap multimeter. Now this multimeter, I have no idea why, but for some reason they have a square wave output. Because again, so far everything we have seen, it's not from outside object, right? It's a EM wave. Again, unless you are doing radio, it's no use here. So what about going from source? Okay, let's activate it. Tada! So there is a square wave generator in all the cheapest multimeter. Do not ask me why, but it is there. Now again, you see this will happen. This is why I'm saying practice. So my first instinct is, let's scale it down. Okay, now I'm getting something. Scale it down, adjust it so it's properly aligned. In this axis, I'm aligning it in this axis. Okay, now I'm not happy. This is dancing. Why it's dancing? Trigger. So I'm gonna let the trigger come in. Still not good. No problem. Do not think too much about it. Just flow. Do not just go Tokyo drift on it. Just let it flow. You see, now the triggering is happening correctly. Again, there are slope triggers, all that trigger. Do not worry about it in early stages. Just figure these things out. So you must have a trigger in a proper clean part of it. This part is noisy. This part is clean. That's why if trigger is here, for example, you see it will start dancing. It's not stable enough. But once you have it down below, at this edge, rising edge or falling edge, whatever have you, it's very clear. It's like, I got this, fam. It's kind of hard to do in sine wave, but in square wave, you're gonna get this amazingly. So this is how I know my multimeter is working. I'm getting a square wave output. Things are nice. Things are fancy. So let's up a bit. Let's upgrade the multimeter. Now this is a big ass multimeter. Do not ask me which brand it is. This is BEE Tech multimeter B595. Now this puppy has a square wave generator which has a bit of oomph to it. So let's dive deeper into it to understand another vector of it. So you connect positive and negative. Negative generally goes to the ground and you connect the positive. Voila. Again, see, this will always happen. Do not panic, do not freak out, just relax and just let things go. This is a newer multimeter, so I think battery is right. That's why 50 waves, the signal is very crisp. So let's fill it up. Oh, it's starting to jump out. Come on, do not panic. Oh, I think the signal is clipping. Ooh, barely working. So, okay, I got it. Now, if it's dancing is not stable, generally means trigger requires some love. So let's put some love on the trigger. It should start to work very nice, nice, nice. Trigger is nice now. Okay. Now, generally, most oscilloscopes have advanced function into it, so where you can see things. For example, let's take an example here. Let's figure out this tiny thing. Measure. So measure will again horizontal and vertical, x and y. That's always the case. So let's look into horizontal. Horizontal is time. So time, I want to figure out the frequency of this puppy. Okay, I click the frequency. Now you can see 50 hertz. Every multimeter will have multimeter. I'm saying most likely if cheapo multimeter has it, big ass multimeter has it, most multimeter will have it. So I get that. Okay, it's 50 hertz. Now here's the deal. You have to understand time. Again, amplitude is very easy to understand because it's voltage. You understand voltage. But time is a bit tricky because you have to understand it must fit inside the basically the time frame, the virtual space that you are observing. If you do not, it will not work. So as you can see, I exceeded the virtual space. It was able to count 50 hertz. And be mindful, the oscilloscope is rated for 100 megahertz, this one. Why the heck it cannot see it? Because it exceeded the virtual space. It's no longer reading it. So I zoom out. That's why people pay attention to like fit everything in this virtual space. You must do that. Otherwise, no calculations will make sense. So let's say I started with 50 hertz. Now I'm going to go 100. Now you see it halved. That's how it works. That's why the graph is so important. 200. Now it's even smaller. 300. 400. But now you may like, okay, it's becoming noisy. I cannot see it. No problem. That's why we have time variable. Now you zoom in. You generally want to have at least 4 clean symbols, 4 or 3 at least. You must have like 4 events, so to say, happening. Now let's go more. Now I have 600, 700. It's starting to become too noisy. I cannot see the crispness here. So you make that. This is 2 if you really want to dial in what exactly is happening, especially if you have any peaks here, surges here, things of that nature. You may want to look into that. But generally prefer 3 or 4. Let's go more. 900. Mo. 1 kilohertz. Yeah, I have no idea why this has this, but it has it. So 1 kilohertz. 2 kilohertz. 3 kilohertz. Now it's starting to be like 2.99, 3 kilohertz. But you see, it's starting to become very congested and it's no longer stable. I think it's no longer stable. Let's zoom into it. And this will happen once you start to go into higher frequency. This will happen. So again, this is a cheapometer. It's not an industrial grade system. How high I can go? 4, 5. Okay, it resetted. Here it shows 50 hertz. It reset because it exceeded the virtual space. So unless you can fill it back up into the virtual space, you're not gonna get anything. Ta-da! That's why do not panic. Understand this X, Y, and trigger. Nothing else matters. Let's close the result part. How do I close it? Measurement. Ta-da! So that's is the core principle of oscilloscope. All oscilloscopes have this, where the buttons are, where the knobs are, how they behave. Read the freaking manual for it. But that's all there is to it. X, Y, and trigger. And again, get a feel for it, get an intuition for it, and that's why you'll see everybody's like knobbing, and they are not paying attention to it. It's like, oh, what's happening? Oh, like it could be anything. Let's do anything. Okay, I have no idea what's happening. Okay, so let's try to figure it out. Okay, this is happening. Let's try to bring it to 0. So I have a bit more control over it. Let's make it wider. Okay, voila. Okay, the signal is not stable. That means the trigger event is not working properly. Let's make the trigger proper. Again, I'm not seeing anything. Let's make the time proper. That's all you have to do. This is the starting phase. Let that be very clear. It goes much deeper. But if you can get these 3 core components, trigger and basically the voltage amplitude and the time vector, fit everything that you are looking into this virtual space, you good. You already are at 80% mark. Everything else just adds on to it. So these 3 things must be your, like, just muscle memory. You should not need to like, what is happening, how is happening. Just have patience, go YOLO on it, practice, and you're gonna be awesome. So this was my presentation on basically first part of an oscilloscope. I hope you can get a start. Please read the manual, and if you liked it, learn from it, something like that, please click like and share it amongst your friends. That will help me a lot. If you didn't like it, didn't enjoy it, I urge you to press it twice to show me extra disappointment, and I'll see you again on the next video. Bye.